In this video, we'll talk about 9.6, which is secant and angle measures. So a secant is going to be any line that intersects a circle in exactly 2 points. Okay, so it's going to be a line that's going to go through the circle and it's going to go through it and touch it at 2 different places. We have the first theorem here, 9.12. If 2 secants or chords intersect in the interior, that means inside of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angles. So here we have the first example. If we were looking for angle 1 is right here in the circle. We would have to take the measures of the 2 angles that it intercepts. So in this case, we would take AB, which is shown right there, and adding the measure of DC or CD, which is right there. We're going to add them up, and then we are going to divide by 2 or multiply it by 1/2. It means the same thing. So you're essentially finding the average of the 2 angles that are on the outsides of the angle that you are referring to. Okay? So here, let's go ahead and go to the first example. We are looking for angle X. X is right there. So if it helps to kind of outline the 2 lines or chords that are creating this angle, and then this will help you see which arcs you should be adding up and finding the average of. So to find the measure of angle X, I'm going to find the average, or 1/2, of the 2 measurements. So the top one is 88, and I'm going to add the other one, which is 76. And this can be done in the calculator. If you prefer to work with decimals, you can change that to 0.5. That might be easier. And then you can go ahead and just find the sum of 88 plus 76 gives you 164. And then go ahead and multiply 0.5 times 164 gives you 82. So the measure of angle X is 82 degrees. And that would be your answer. So you found this angle measure right there. Okay. Example number 2. Again, we are looking for angle X. Angle X is right there, so it might help to show which lines are used to find it. This one, we can go 2 different ways. Looking at these arcs, I don't have any measurement here. I could find them, but another approach we could take is, I know we're looking for X, but actually if I just find this angle here, I already have those 2 arcs that correspond. I already have this one and this one. So once I find it, I can subtract from 180 because they make a line, and then that's how I can find angle X. So that's going to be the approach I take here. Okay, so I'm going to find the angle that I marked that's not angle X, but it's going to help me. So I'm going to just call that angle Z because there's a Z already there. So angle Z is going to be equal to 1/2 times, and then add up the 2. So this is 96, and the other one that's intercepting it is 62. So when I do that in my calculator, remember that you can turn this into a 0.5 if you like that. I'm going to take a moment to put that in, 0.5 times. And then if you include the parentheses right away, it should go ahead and solve it for you. So when you do that, you should get 79 degrees. And again, this is for this one right here, which is not X, not the one we were originally looking for, but it's going to help us. So 79 and X are a linear pair. So I can figure out what X is by subtracting from 180. If I do 180 minus 79, I get 101. So the measure of angle X in this case is 101 degrees. Again, I went ahead and used the other angle to help me find angle X. You could figure it out another way. I just figured this was an easier way to do it in this case. Okay, so far we've been using the outside arc measures to find the inside angle. But now example 3 is going a little bit backwards, so we know what the inside angle is. Okay, and X happens to be on the outside. So we're going to set up this equation a little different. This time, we know the inside angle measure is 60. Okay, and that is equal to 1/2 the 2 outside arcs added up together. So the first one I don't know is X, and I'm going to add that to the other one I do know, which is 25. Okay. And thinking about how we are solving for X, your goal is to isolate the variable. So in this case, you have a 1/2 that you should get rid of. Okay, 1/2, it's a fraction, so 1 divided by 2. And thinking about the opposite of a fraction, so you can cancel it out, the opposite of division is multiplication. So if you go ahead and multiply both sides by 2, the only thing that's going to do on this side is cancel out the fraction. So all you are left with on the right side is x plus 25. And on the left side, if you simplify 2 times 60, you get 120. From here, it's just a one-step equation. You can subtract 25 from both sides, and that isolates your x value, your variable, and you get 95. So this time, x is 95 degrees. It's on the outside, so we just substituted the values a little bit differently. Okay. And example number 4 here, you're going to do the same thing we did with example 2, kind of working backwards. We are looking for x, but in order to find x, I'm actually going to use the information that I have for this angle so I can find it and subtract from 180 to solve for the x value. So in this case, if I find E, I'm going to do 1/2 the two outside arcs, 92 and 72. Okay, when I put that in my calculator, I get 82 degrees. So I just found this one, but I still want to solve for x. Remembering that x and 82 are going to be a linear pair. So I can do 180 minus the 82 I just found. That gives me 98 degrees. So the measure of angle x is 98 degrees. And again, we use linear pair for that. Okay. Next theorem, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so here, what this is saying is that the measure of angle 1, so that's this right here, is going to equal half of AB. So AB is all of this. The measure of angle 1 is just going to be half of that. So for example, if angle 1 was 60 degrees, then the measure of AB would be double that, 120. Okay? If measure of angle 2, let's say, I'm going to put the words if in front of that. If the measure of angle 2 was 120 degrees, let's say, then the major arc A to C to B would be double that, 240 degrees. Now, I want to show you something here. The measure of angle 1, like I said, if that was 60 degrees, together, 60 and 180, they form a line, right? They add up to 180 degrees, which is a line. And if I add up this part of the circle and this part of the circle, 120 plus 360, that equals, or 240, sorry, that equals 360, which is the entire circle. So this should make sense. A line is 180, a circle is 360, so you put them together and they should add up to be what they are by definition. So let's go ahead and try some of these examples. First one, find QPS. From Q to P to S. So just focusing on this, here's the information we know. We know that the angle, the measure of the angle QPS, is going to equal half of the arc. How long or how big is the arc? This whole arc shows to be 250. Okay, so you can either, again, change it to a decimal or think about it. You're finding half of 250, so you can do 0.5 times 250 or 250 divided by 2. Either way, the measure of angle QPS is going to be 125 degrees. So think of it as just like dividing it by 2. If you're given the big angle and you want to find the little one, just divide by 2. Now, if you're going the other way, like in the next example, you want to find B, C, D. Okay, so BCD is going to be whatever DB is not. Okay, so I'm going to kind of go backwards and solve for it here. So I'm going to solve for DB first, the green. So DB, and I know that's not what I'm looking for, but because I'm giving the little angle, I know that this is going to be double that. So essentially I'm taking 108 and multiplying it by 2. So that is 216 degrees right there. Okay, so that's the measure of DB in the green. But I'm looking for BCD, and BCD is going to be the remaining of a circle. Now a circle adds up to 360, and I don't want the 216 of that. So that means that the remaining measurement is going to be 144. So the measure of BCD is going to equal 144 degrees. So once you get to that point, you can use any of the theorems that we know so far, that circles add up to 360, lines add up to 180. If you're given the intercepted arc, you multiply by 2 to get the outside one, or if you're given the outside one, you divide by 2 to get the intercepted arc. Okay, next theorem we have is 9.14. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measurement of the angle formed is 1/2 the difference, which means we're going to be subtracting, of the measure of the intercepted arcs. Okay, so we can give you any of these combinations. We can give you two secants. And remember, a secant goes through the circle at 2 points. Here's one secant. Here's another secant. A secant or a tangent. So this is a secant again, but then the tangent just goes through it once. Or two tangents. And two tangents would just mean they touch the circle exactly once. So any of those combinations, you are going to do the exact same thing, okay? So if you're looking for the little angle A, the part that's sticking out, okay, if you're looking for A for all of these, what you're going to do is you're going to take the furthest angle away and then subtract the closest angle to it, okay? So again, take the furthest angle away, subtract the closest angle to it, and one more time, take the furthest angle away, this one, and subtract the closest angle to it. That's how you're going to find angle A. Now you just want to make sure you pay attention to what you're given, and so you might need to substitute the values a little bit differently, but the smallest angle equals outside minus the inside, whatever is closest to it. So if we go right into the examples, pay attention to what you're being asked for. So BC in this case, I'm looking for this, okay? So the smallest angle in this case is 62. So I'm going to say 62 equals the furthest angle away. The furthest one away is 141. And remember that there is a fraction in front of us, so you are going to divide by 2. So the 1/2 is always there. And then furthest away is 141 minus closest to the small circle is BC, what we're looking for. So I'm just going to put BC there. Think of BC like an X value if you want, okay? And think about the procedure that we talked about. How do we get rid of that fraction? So to get rid of the fraction, we're going to multiply both sides by 2, and that's going to cancel out the fraction on the right, leaving me with just 141 minus BC. And then I have the 62 times 2 gives me 124. So we're going to subtract the 141 over to the left side. That leaves me with negative 17 equals negative BC. Now notice that negative, it's an easy fix because both sides have a negative. You're just going to multiply by -1 or divide by -1, however you want to think of it. But BC comes out to be 17. So the measure of BC is 17 degrees. Okay, so little angle on the outside is equal to 1/2 big angle minus smaller angle closest to that one. Okay, let's do it again. Go ahead and pause the video. This is the exact same picture, just different numbers. For example, number 8. And when you have tried it, go ahead and keep playing. So in this case, we have the little angle on the outside, 56, is going to equal 1/2 the furthest angle away, 135, minus the closest angle, which happens to be what we are looking for, QS. We are going to multiply both sides by 2 so we can get rid of that fraction. The left side, when I multiply that by 2, is 1/12. The right side is 135 minus the value that we're looking for, QS. We are going to subtract 135 from both sides. That gives me negative 23 is negative QS. And again, because they're both negative, you can kind of just go straight to the measure of QS is positive 23. You want to make sure your answer is positive. So if one side is negative, the other one is probably going to also be negative because they need to cancel out. Okay. 2 more examples here. This time I'm looking for the furthest away angle, XYZ. XYZ is the outside part. So set it up the same way, right? We have the little one, 40, is equal to 1/2. The furthest away is the one I'm looking for. So XYZ minus the closest one is 140. Same process, we're going to multiply both sides by 2 so I can cancel out that fraction. That leaves me with 80 on the left side. And then XYZ, which is what I'm looking for, minus 140. Now this time, I'm going to add 140 to both sides. So this time I'm not getting a negative answer. I have 220. And that equals XYZ. So the measure of XYZ is 220 degrees. Okay. One way to check that this is true, if we look at just the circle part, a circle adds up to 360, yeah? So if I add 140 plus 220, that's 360. That makes sense. Last example in this set of notes. Go ahead and pause the video and try it. It's the same thing that we did for example 9. And when you're ready, go ahead and click play. Little angle, 50, is going to equal 1/2 the outside angle, which is what we're looking for, FIH, minus the inside angle, which is 130. We're going to multiply both sides by 2 to get rid of that fraction, which leaves me with 100 on the left, FIH, which is what I'm looking for, and minus 130. To solve for FIH, I'm going to add 130 to both sides. So I end up with 230 is the FIH. So to write it, it's my final answer. The measure of FIH is 230 degrees. Okay, the last part, we just have this table that kind of ties it all together for us. So if the vertex of the angle is on the circle, so notice how the angle is on the circle, I'm going to take 1/2 the measure of the intercepted arc. So angle 1 would be half of x. If the angle is inside the circle, so notice how it's inside the circle, I'm going to add up the 2 ends and then divide by 2. If the angle is outside the circle, so it's sticking out of the circle, then I'm going to subtract and then divide by 2. So this table kind of ties it all together for you, so you know which formula to use. And this is definitely something you would want to write down on a note card or whatever you're allowed to use on the test if you're able to. And that's the end of the notes.